Expecting you put it where the sun is, it would unwind to the circle of Jupiter, a monster totally shaky and going to explode. They are among the most observable impacts of radio energy in the entire universe, conveying more energy than a billion suns. Bug Jew, or startling crawly Jew, is a red Goliath star. Assuming you put it where the sun is, it would connect with the circle of Jupiter, monstrous, absolutely inconsistent, and moreover going to explode. When we think about stars, we no doubt imagine irrelevant glinting things in the night sky. Basically, this is how we see them from down here on Earth. Yet stars are something completely different. As a matter of fact, maybe quite possibly one of the most prominent stars, Betelgeuse, is fundamentally more critical than our sun. For quite a while, this star has perplexed agents. Anyway, truth be told, something additional upsetting has been happening with Bug Jew, making inspectors and other very achieved individuals extraordinarily concerned. Go along with us in this video as we investigate the grand new data about Bug Jew, its coming obliteration exactly as expected by the James Webb Space Telescope, and how this new advancement will impact our universe and our lives here on Earth. As made sense of by physicist Michio Kaku, Bug Jew is a gigantic marvel, a giant star that has fascinated cosmologists for so long. A Greek space expert named Antonius was the first to find it. This star is so immense that it tends to be viewed in the night sky from Earth, particularly during winter. In the event that you're into cosmology, you've without a doubt seen or caught wind of the star. The becoming flushed orange star means the upper left shoulder of the Orion heavenly body. So you see, this star is obsolete and thus far, maybe one of the most glorious stars in the evening sky. Yet one thing about frightening little creature Juice's brightness is that it doesn't stay dependable. Rather, it differs. This change is one of the great properties of the star, but it isn't the only one. We ought to explore some of Bug Jew's specific properties. The greater part of the stars you find in the night sky are a long way from Earth. The nearest star is 4.2 light-years from Earth. In case that you dismiss how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been shown how light can cover a distance of 186,000 miles. Thus, the distance light can cover in a year is essentially comparable to 1 light-year. Predicting you crunch the numbers, you'll have billions of miles. So, when we say the closest star is 4.2 light-years away, it means it is, regardless, billions of miles from Earth. Look at this, some stars are farther, and Bug Jew is one of them. Bug Jew is tracked down around 600 light-years from Earth, so assuming that you somehow wind up going to it at the speed of light, it would in any case require 600 years. We can't move that quick. Not even our speediest space rockets can. However, this star can in any case sparkle so brilliantly in our sky. If you're considering how Bug Jew can be so great regardless of its distance, that is a result of its unique attributes like size and quality. Bug Jew is on numerous occasions more enormous than our sun. Its range is recognized to be commonly that of the sun. Tragically, it shows up as a disk in space while utilizing current telescopes, while various stars show up as nearly nothing places of light. This is accepted to be an impact of the reactions at the external layers of its air. In regards to mass, Bug Jew weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass utilized by space researchers. One solar mass is like 2 by 10 to the power of 30 kilograms. Specialists can't pick the specific mass of Bug Jew since there are no other planetary bodies circling around it to look at it with, and obviously we can't gauge it straightforwardly from here on Earth. At any rate, this makes Bug Jew on numerous occasions heavier than our sun. The brightness of Bug Jew goes from size +0 to +1.6. In more undeniable terms, Bug Jew is ordinarily more amazing than our sun. No great treat, it was nicknamed a red giant. At any rate, the quality of Bug Jew doesn't stay solid. It differs. This change is due to its pulsates, or in other words, Bug Jew expands and contracts. When it extends, it gets more brilliant. At the point when it contracts, it reduces. This cycle can endure for 10 to 100 days, or indeed, even significantly longer. A clever property of Bug Jew is that its surface is canvassed in dull, attractive spots. The attractive field here is far more grounded than at the normal surface. Anyway, the drawback is that these strong, attractive spots slow down the progression of hot gas to the star's outer surface, making the star cooler in these areas. The reality that Betelgeuse has so many of these spots, contrasted with our sun, makes sense of why it is cooler than our sun notwithstanding its size and splendor. The sun likewise has its own dim attractive spots, but those on Betelgeuse are a lot larger and altogether more numerous. To give you an idea, the spots on Betelgeuse can be 2 times as broad as Earth. Betelgeuse flaunts an attractive field that is a large number of times more grounded than that of the sun. This field is the explanation that when seen through a telescope, the gases on the external layer of Betelgeuse appear to be whirling around or twisting. Betelgeuse has a surface temperature of around 3,500 K. This low temperature adds to the low energy discharged by the star and its feeble red variety. Frightening little creature Ju is a red star, but it wasn't always red. It was yellowish something like a long time ago, like our sun. Over the long run, the variety started changing to orange, red, and then about 1,000 years ago, it slowly began changing into the red star we know today. This reality has led scientists to believe that the star is developing. Betelgeuse produces as much as several times more energy than the sun. It would have been a maddened contender to Earth's sun if it weren't so far away. The way that Betelgeuse, which is 600 light-years away, can still be seen and related with the naked eye around evening time is incredibly striking. Our sun is simply 8.3 light minutes from Earth. That's why it's so strong. If Betelgeuse were just a little closer, we would also be able to see it during the daytime. But if it somehow managed to replace the sun, it would consume or displace the Earth and the other 4 planets close to it because of its enormous size. Other than whether it were to match the sun in size, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is an extremely giant star located in the star group Orion, about 600 light-years from Earth. Its immense size is potentially one of its most striking parts. It is ordinarily more significant than our sun with respect to its size and could easily include the circle of Jupiter if placed at the center of our solar system. This unbelievable size permits Betelgeuse to show up as a disk instead of a point of light when seen through strong telescopes, not at all like most different stars. Despite its huge size, Betelgeuse isn't the most giant star. Its mass goes from around 12 to 19 times that of the sun. This variety in mass estimates is due to the difficulties in precisely estimating the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a giant heavenly body. The brightness of Betelgeuse is another key characteristic. It varies reliably over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be several times more brilliant than our sun. This change is ascribed to its pulsates, intermittent extensions, and contractions brought about by inside cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it darkens. These pulsates can last for a long time, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red hue, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, showing dark magnetic spots on its surface, where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a colossal, brilliant star, but it will ultimately meet its end in a glorious cataclysmic explosion. Betelgeuse is a massive star advancing toward the end of its life, and its potential fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a tremendous blast, a powerful event that marks the death of a massive star. The force of a supernova is strong enough to quickly obliterate an entire system. This phenomenon could even send shockwaves through space, and it's possible Betelgeuse will experience such a dramatic end very soon. This fate, while not inevitable, is something researchers are closely studying to learn more about the fate of stars and the evolution of the universe. As Betelgeuse approaches the end of its stellar life, astronomers are paying close attention to its behavior. The star is expected to go supernova in the end, a destructive event that will result in the release of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a catastrophic event in a star's life cycle, signaling the final stages of its evolution. Betelgeuse's possible supernova could be visible from Earth without the aid of a telescope, given its immense brightness and relative proximity. This explosion would release enormous amounts of energy, creating heavy elements like iron and nickel, which are essential for the formation of planets and other celestial bodies. These elements would be scattered throughout the universe, enriching the interstellar medium and contributing to the creation of future generations of stars and planets. Interestingly, scientists have been able to detect unusual changes in Betelgeuse's brightness recently, leading to speculation that the star could be approaching the edge of a supernova. However, despite these fluctuations, it's difficult to predict exactly when the star will explode. Some researchers have suggested that Betelgeuse could go supernova within the next 100,000 years, a brief period in the life of the universe, but still too far away to pinpoint exactly. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow researchers to study the star's outer layers and magnetic fields in extraordinary detail. JWST findings have confirmed the star's ongoing changes, including its irregular brightness and potential instability. These observations provide crucial data about the processes leading to a star's death, offering a better understanding of stellar evolution. Betelgeuse's demise will have wide implications for the universe. The supernova shockwave could possibly trigger the formation of new stars in the surrounding area, aiding the cycle of stellar birth and death. Additionally, the elements created by the explosion will spread throughout space, contributing to the building blocks of new planetary systems. In the grand scheme of cosmic evolution, the death of Betelgeuse will not only mark the end of one of the largest stars we can observe, but will also pave the way for the next generation of celestial objects. Despite the fact that we will not be around to witness the star's final moments, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death, and it offers a glimpse into the fate of other stars with similar characteristics in the future. Scientists hope to continue studying Betelgeuse with the help of cutting-edge technologies and space observatories. The information gathered from the star will continue to shape our understanding of astrophysics, assisting us in unlocking the mysteries of how stars evolve and what their violent deaths mean for the universe. All in all, Betelgeuse, as a massive and dynamic star, is an essential part of the celestial puzzle, and its eventual demise will be one of the most fascinating events in the history of our universe. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing and evolving as Betelgeuse approaches the final stages of its life. Astronomers continue to gather critical data on its behavior and potential supernova event. Understanding its evolution will provide valuable insights into the broader processes that shape the universe. Stars like Betelgeuse, which are nearing the end of their life cycles, undergo dramatic changes that offer astronomers a unique opportunity to study stellar death up close. The massive release of energy from the supernova will illuminate the surrounding space for a brief period, allowing scientists to observe the intricate processes involved in the death of a star. Moreover, the elements created in a supernova, such as heavy metals like iron, carbon, and oxygen, are essential for the formation of planets and life. These elements are dispersed throughout the universe by the shockwave, enriching the interstellar medium and providing the building blocks for new stars and planetary systems. This process plays a crucial role in the cycle of stellar birth, life, and death, contributing to the ongoing evolution of galaxies and solar systems. One of the most fascinating aspects of the study of stars like Betelgeuse is the insight it provides into the future of our own Sunday. While our sun is far less massive and will have a different fate, Studying massive stars like Betelgeuse helps scientists understand the potential outcomes for other stars in the universe. These findings can inform our understanding of stellar populations and how they evolve across cosmic time. Furthermore, Betelgeuse's eventual demise will highlight the dynamic and constantly changing nature of the cosmos. Even though we won't witness this event in our lifetimes, the information gathered from Betelgeuse will continue to influence scientific thought for generations to come. The study of such massive, evolving stars will remain an essential part of astrophysical research, helping to unlock the mysteries of how stars live, die, and shape the universe. The study of stars like Betelgeuse also helps refine our understanding of the larger cosmic cycle, which encompasses the birth, life, and death of stars across the universe. By examining how massive stars undergo their final stages of evolution, scientists gain insights not only into their individual life cycles but also into the broader patterns of stellar dynamics. This understanding is pivotal for studying galaxy formation and evolution, as stars are fundamental building blocks in the development of galaxies over time. In addition to advancing astrophysical research, the study of Betelgeuse's eventual supernova will provide a better understanding of the types of radiation and cosmic events that influence nearby stellar systems and even the intergalactic medium. When a star like Betelgeuse goes supernova, the sheer power of the explosion can impact surrounding space, triggering the formation of new stars or disrupting the balance of neighboring star systems. The explosion's aftermath is significant for the universe as a whole. The debris from the explosion, including heavy elements, will spread throughout space, potentially impacting the composition of nearby nebulae and facilitating the creation of new planetary systems. This cosmic recycling process plays a critical role in the ongoing evolution of galaxies and will shape the formation of future celestial bodies for billions of years.